Hi, thanks for checking this project out. This is the Scratch Plate MIDI controller. It uses an Adafruit feather to send MIDI notes to a MIDI compatible synthesizer using Bluetooth LE. And note presses are detected via capacitive touch sensing done on the exposed ends of 12 wires that I have stuck to the scratch plate of the guitar. So let me briefly demonstrate how it works. Each one of these wires corresponds to a note in the chromatic scale. So from C to B. And the advantage of having wires as opposed to capacitive touch pads, which you could do by covering the ends of the wires in capacitive foil, is that you can orient the wires however you like. So I tend to orient down the wires that correspond to notes I won't be using in a particular song, and only have the notes that I want to play oriented up. So these wires feed into a capacitive touch sensing breakout board, which then communicates via SCL and SDA clock and data lines with the Adafruit feather. Now I'll talk through the different components on the board. So there are 3 push buttons, 2 potentiometers, and a toggle switch. So the push buttons change octave, either octave down or octave up. And you'll notice there's a 4-octave range here, but that can easily be configured by changing the code. The other push button enables or turns off sustain mode. So in normal mode, I can play many notes at the same time. In sustain mode, I can only play one note at a time, and the note will hold even when I'm not pressing it with my finger. Pressing the same wire again will cancel the note. Now, pressing either of the octave buttons or the sustain button cancels all preceding note events, so you don't have to worry about overhanging notes that aren't properly cancelled when you're performing. The 2 potentiometers change continuous controller values. One of them changes the CC1, which normally corresponds to the mod wheel. In this case, this changes the cutoff frequency. The other potentiometer maps to continuous controller 7, and this changes the volume. Oh, and the end of the potentiometer just fell off there. And finally, there's a toggle switch, and the toggle switch turns the feather on and off. Now what I'll do is I'll show you how you can mount the feather and dismount it from the guitar. So I'll just turn the feather off. So the MIDI controller is mounted using hook and loop tape. I use PVC tape, which is the green tape here, to protect the finish of the guitar from the adhesive on the hook tape. I then stick hook tape to the scratch plate of the guitar and loop tape to each of the wires in my MIDI controller. This means that I can easily and reversibly mount or dismount the controller, as I'll show you now. So as you can see, it's not a perfect system because one small part of the loop tape came off a wire there. It's easy enough to fasten back on, and it has been working well for me, but if you can think of any improvements to the mounting system I'm about to show you, please do let me know. So once the wires are dismounted, then I can dismount the capacitive touch sensing breakout board. Now notice the whole board is wrapped in PVC tape. That's essentially to insulate it and prevent any unwanted note presses happening on the board itself as opposed to the exposed ends of the wires. The wires connecting the breakout board with the Adafruit feather, which are clock and data lines, power and ground, and an IRQ interrupt line, are bundled together similarly with loop tape and can just be unstuck like that. And then finally, the microcontroller itself, along with the buttons and the battery that powers it, can be disconnected. Oh. Just put my guitar there. Okay, so now I have the disconnected controller, and it can be mounted again relatively easily. You'll notice that the battery sits on the bottom of the microcontroller proto board, and it too is fastened to this board with hook and loop tape. This makes it easy to get the battery on and off to do repairs to the board, or if you need to change the battery. One of the neat things about this board is that it can be powered directly using a JST PH connector to a LiPo battery, and when you plug in the board using USB, you can then recharge that battery. So it makes a sustainable recharging system. A final thing is, you'll note I use two proto boards here. The purpose of the second one is just to make a flat surface that I could have stick the battery to. So thanks for watching this video. If you're a guitar player or a musician and you decide to make this device, I hope it's useful, and if you have any questions, just let me know via the comment section of the Arduino Project Hub tutorial, and hopefully it will be a good way to explore new sounds in your music.